Welcome to our talk. My name is Nathalie and I'll present our paper Input Visualization, Collecting and Modifying Data with Visual Representations. This is a collaboration between myself, Jean-Louis, Wesley, Willett and Samuel Huron. The area of information visualization has traditionally been concerned with visualizing existing data. Yet there are a variety of visualizations that do not follow this approach and instead use visualizations for data input. We call these visualizations input visualizations, visual representations that are designed to collect or modify new data rather than encode pre-existing datasets. To help unpack this idea, I will start by highlighting 4 case studies. The New York Times' The Death of a Terrorist was published in 2011, just after the killing of Osama bin Laden. This interactive visualization let viewers indicate their feelings about this event by marking a point in a 2-dimensional scatter plot with significant, insignificant, and positive-negative axes. Over a few days, these inputs created a visualization of readers' overall sentiments with over 13,000 data points. Another common example of an input visualization is Doodle. Doodle is an online scheduling tool for facilitating meeting coordination. It allows multiple participants to collect and visualize schedule availability based on a preference matrix and timeline. An example of an input physicalization is Karen, which uses a tangible tabletop to enable data collection and sharing in a community makerspace. Karen used a much more complex visual encoding schema with composable physical tokens that let makers record both quantitative and qualitative information about their projects. Lastly, the visual backchannel tool Polemic Tweet used visualizations to engage users in an evolving discussion around conference presentations. Polemic Tweet included a Twitter client that invited viewers to tweet using a specific grammar, including ++ for agreement or 2 question marks for questions, and then visualize these tags alongside the discussion. These case studies, along with others, showcase a diversity of physical and virtual input visualizations, including both straightforward examples and ones that challenge visualization norms. By emphasizing data input and modification rather than traditional visualization goals like perception, exploration, or communication, input visualizations force a rethinking of the relationship between data and visuals, since they invert traditional information visualization models, design guidelines, and interaction taxonomies. Recognizing the potential for visualizations as data inputs opens up opportunities for unexamined use cases, new interaction techniques, and visualization tools that support new ways of engaging with data. With this project, we aim to conceptualize and describe the phenomenon of input visualization to make it actionable for the community, and investigate characteristics of existing input visualizations. By doing that, we aim to open up new research opportunities around input visualization. We did this by creating a design space of existing input visualizations. We collected 50 curated examples of input visualizations from research, art, commercial products, journalism, and personal projects. We coded these examples based on 16-dimension and extracted purposes of input visualizations and a set of design considerations. Our process encompassed multiple phases in which we used a variety of physical and digital tools for our analysis. Our resulting design space includes both visualizations and physicalizations that are specifically designed to support data input. The examples of our corpus are also available in the supplemental material and on a companion website. We organized the 16 dimensions into the 5 high-level categories: visual representation, data, artifact, context, and input. We saw a diversity of visual and physical idioms, including both common idioms such as bar charts, as these physical bar charts at an exhibition, or scatterplots as in The Death of a Terrorist. We also observed examples that consist of a mix of idioms, like Doodle, which is a mix of a timeline and a matrix, as well as custom idioms, like this conference data badge, which encodes information about the wearer. We found diverse types of categorical, ordinal, text, and quantitative input data. Although activity tracking and subjective judgments like feelings and opinions were especially common. An example of this is Considerate, a deliberation platform. The number of data dimensions also varied from just 1 up to dozens, as in Karen. The artifacts in our collection included visualizations on a variety of display types, as this communal plant watering tracker. and physicalizations made from a diverse set of building materials, as this physical parallel coordinates visualization made out of string, nails, and wood. While some examples were highly customized artifacts intended for a single purpose, as this pole that was exhibited at the MoMA, a range of commercial products and toolkits also allowed people to author their own input visualizations, like the Let's Play with Data kit. The input visualizations in our corpus were not limited to a certain domain, and many came from areas that are underrepresented in information visualization research, like personal tracking, time management, and civic participation. Our examples supported various timelines of use ranging from minutes to months or indefinite timeframes, like a personal calendar. They also supported diverse numbers of participants, from individual users to multiple thousands, like a Twitter poll that enables input for a large number of people. We also identified examples that supported a variety of high and low-level tasks, as well as synchronous, asynchronous, co-located, and distributed input. While many examples use tokens as they can correspond one-to-one with a row in a dataset, we also saw a variety of other input modalities, including interacting with controls, drawing marks, forming materials, interacting with the body, and authoring words. Although physicalizations typically relied on embodied interactions, visualizations incorporated a wider range of mediated and indirect input approaches. By clustering the examples based on high-level task, number of participants, data visibility, synchronicity of input, and type of data, we identified 7 purposes for input visualizations based on common characteristics. Individual self-reflection focuses on personal data collection by an individual to support self-knowledge. These include tools for capturing subjective judgments and activities like these self-trackers. Public group reflection examples allow multiple people to collectively reflect on a topic, like Consider It or the MoMA poll. Public activity documentation examples document ongoing group activities, like Karen or the plant watering tracker. Data discussion examples operate synchronously and allow ongoing collective discussions mediated by the input visualization, like polemic tweet or simple dot voting techniques. Survey examples aim to collect data from a group of people, but the existing data is hidden during input and only shown afterwards. This is the case for a Twitter poll or feedback frames, a physical survey example. Planning examples bring an explicit focus on time and logistics, helping people make sense of ongoing time use, develop plans, and forecast future events like Doodle or a calendar. Finally, organizing examples focus on sorting and categorizing, often allowing viewers to change data points, attributes, or even data dimensions like affinity diagramming or a tier list maker. Based on our design space, we identified a number of design considerations. I will highlight the first 2. All input visualizations are dynamic by default and need both an assembly model and an approach to deal with dynamic data. The exact quantity, scope, and nature of the data that will be collected with an input visualization is often unknown at the time it is created. We have seen several strategies to deal with these challenges, including aggregation and binning of input data, as seen as in the death of a terrorist, or dynamic visual mappings and adaptive scales that show a limited amount of data to reduce clutter. For instance, marks in the plant watering tracker gradually fade and disappear. Similarly, tokens in Bubble TV shrink over time using a metaphor of visual sedimentation. A subtractive approach, as in the Happy Show, has a similar effect, with participants removing tokens from the bars, which reduces visual cluttering over time. However, scalability concerns are perhaps biggest for physicalizations, which likely require routine maintenance like restocking of input materials or manual removal of elements when the view becomes too cluttered. Another design consideration is how the design choices influence the data people will input. For example, whether existing data is visible during input can have an impact on subsequent data collection. Survey-style designs reduce the possibility that existing data will influence the new values. Next to digital approaches, like a simple Twitter poll, there are even physical ways to create survey input visualizations, such as feedback frames. On the other hand, public group reflection designs often explicitly surface prior data to provide context, create social engagement, or support reasoning based on prior responses. This means that each data input reflects a different state of the visualization, so the values are not comparable in the same way. Instead, these visualizations tend to serve as collective social artifacts that evolve over time. For more information on the other design considerations, please refer to our paper. Taking a step back, thinking of visualizations as input spaces opens up possibilities not only for data collection, but also a variety of sense-making tasks. Our workflow for this paper, for example, contained many iterative rounds of data collection, coding, and clustering spread across a variety of virtual and physical platforms. New input visualization tools could support more fluid transitions between interactive visualizations and structured tabular data throughout analytic workflows to support data-informed sense-making, decision-making, and thinking. Input visualization is also not a new phenomenon, but a recognition of a set of existing patterns. Considering these examples as visualizations raises deeper questions about the nature of data and how the information visualization community has traditionally set its boundaries. Input visualizations, for example, collide with epistemological discussions about data itself, particularly when considering concepts like CAPDA and the constructivist nature of data collection and visualization. These considerations become even more important in the context of input visualizations, since they more explicitly surface the mechanisms of data collection. On top of that, most input visualizations don't align neatly with common definitions of information visualization, which usually explain visualization approaches as visually encoding data to make them easier to understand. As a field, we have largely focused on visualization as output. However, there's perhaps an equally large and underexplored area full of research opportunities. Our work represents just a first step towards mapping the broader space of input visualization. With this in mind, we encourage the visualization community to further examine this space, building an understanding of the potential of this approach one input at a time. For further information on the design space and the examples, please refer to the paper, the supplemental material, and the companion website.